All right, Julie, so I'm gonna try to teach you a little bit about how to graph an absolute value equation and then how to solve an absolute value equation. So in order to graph y equals the absolute value of x plus 2, we would need to realize that this is just two linear functions combined. So the absolute value graph is always gonna look like a V, the shape of a V, and one side of the V is gonna be just the equation y equals positive x plus 2, and the other side of the V is gonna be y equals negative x minus 2. These two equations are always opposites. So when we go to graph them, we see that the first thing we would do is start at positive 2, go up 1 over 1, up 1 over 1, up 1 over 1. And if we wanted to continue this in the other direction, we would just go down 1, down 1, down 1, down 1. So this is the first side of my V. And sorry, it's going to be kind of a sketch. Okay? And then the other side of my V, I need to start at negative 2 and go up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. This is the other side of my V. Okay? Now, an important thing to realize is that absolute value graphs can never be negative. So we actually go back and we erase everything below the x-axis because absolute value can't be negative. And so this is our graph of y equals the absolute value of x plus 2. Okay, it hits down the x-axis at negative 2. Now, what we started doing in class this week is we started replacing the y with an actual number. So if I want you to figure out when the absolute value of x plus 2 equals 5, what I need you to understand is that means we're wondering where the graph of x plus 2, the v, is equal to 5. And what we would do is we would draw a horizontal line at 5, and where the V intersects the horizontal line, those are our solutions. So in this case, the first place they intersect should be at 3. This point right here is the point 3 comma 5. And so this is the x value that if we plugged it back into our equation up here, 3 plus 2 is 5, and the absolute value of 5 is 5. Our other solution is over here at negative 8 comma 5. Again, our x value is the solution, because if we come up here and we plug in negative, oh, my apologies. It should have been negative 7. Yep, sorry, it's at negative 7. Check your work always. If I come back up here and plug in negative 7 plus 2 is negative 5, and the absolute value of negative 5 is 5. So, we've been talking a lot in class this week about how to solve equations. But essentially what always happens is we have a right side of the V and we have a left side of the V, and these two sides of the V need to be set equal to the number we want. For example, if we didn't want to graph this, we could have just taken the two sides of the V and set them equal to 5. So first I'll take the right side of the V. That was the line positive x plus 2 equals 5. And then the left side of the V was the line negative x minus 2, and it equals 5 as well. I could solve both of these equations, and I would get the same answers I got from the graph. In this case, x equals 3, and over here, adding 2 to both sides, negative x equals 7. Then I would need to divide both sides by negative x, and when I do that, I get x equals negative 7. So again, I can get my two answers from algebra, or I can get my two answers from the graph. Okay, one more example without a graph. Imagine I had the equation 2 times the absolute value of 2x plus 1 minus 4 equals 8. So I need to be able to solve this absolute value equation. The first thing I need to do is I need to isolate the absolute value. So I'm going to add 4 to both sides first. So I get 2 times the absolute value of 2x plus 1 equals 12. Okay, then I need to get rid of this 2, so I'm going to divide both sides by 2. So I get the absolute value of 2x plus 1 equals 6. Keep in mind these 2's canceled, and up here these 4's canceled. Okay, now from here I'm at the point where I should be thinking about the picture. This absolute value of 2x plus 1, that's just a V. And that V is always going to rest on the x-axis. This line 6 is a horizontal line up at 6. And these two graphs are going to intersect in two places, and it's my job to figure out where. So in order to do this, I set up two equations. One of them is going to be the right side of the v. That's the one with the positive slope, 2x plus 1. I want to know when that equals 6. That's this side of the v. And the left side of the v is the one with the negative slope, and I want to know when that equals 6 as well. Okay? You solve both of these, 2x equals 5, so this solution would be 2.5. That's one of my solutions. And then over here you add 1, negative 2x equals 7, dividing by negative 2. My other solution is negative 3.5. These are my two solutions because these are the 2 points that the v intersects the horizontal line. You should always check your work. So I'll give you an example here. We'll take 2.5 and we'll plug it back in. 2.5 times 2 is 5. 5 plus 1 is 6. The absolute value of 6 is 6. 6 times 2 is 12. 12 minus 4 is 8. That's how I know I'm right. I could do the same thing with this answer and it would also equal 8. So we've been practicing solving equations. Keep in mind that your steps are, first, you need to isolate the absolute value. Then you need to set up two equations. Then you need to solve each equation. And lastly, you need to check that those solutions work by plugging them back into the original. I hope this helps.